Hello and welcome. So this is Jamil. So today's video we're going to continue our tutorial from pacing operations. So previously we already tackled up to 8 blocks. So just to recap. So previously we tackled about this G43, G0, G43. This is supposed to be just G0, supposed to be not there. So G0, G43, H1. So G43 equals tool length compensation. So that's our previous program, which we explained that from this explanation, when we do G43, it always has corresponding H1 at the side, which we explained from our previous blog, which when in our highlights, that H1 is the value of your tool length, which is this 200, and of course H1 is in your tool height, which is this 200. That is your tool height, and the wear is used to adjust incrementally a small amount if you want to target a specific adjustment to your job. Example, your thickness is 200.1, you want to adjust negative 0.1 more, so put negative 0.1 here and don't change your geometry. And also the radius, the half of your diameter, which is diameter 100 cutter, half of that is 50, so we put 50 here in the radius and 0. But right now we don't have we will not using radius at the moment because it's only facing, so we just disregard this information. But to properly set your tool, you have to put 50 here in your geometry. And yeah, so that when the machine read this G43 H1 Z50 M8, so the machine will go 50 mm from your Z0 initial Z50. So example, machine read that, and we position already from the side using that G0, G90, this one, that G90, G54, X225, and Y negative 125. So your tool is already here. And when it reaches M3, S478, the tool is already spinning. So when it reaches G43, say H1, Z50, it will go here, Z50 from the Z0 to Z50, positive Z initial. So the tool will move spinning from that distance, your initial Z, which is Z50. So that's why in this illustration, Z50 from the Z0 to the edge of your tip of your cutter. So now from that position, from this, we will now move going to Z0, and that requires G1. G0 equals rapid, it will move very quick, and G1 moves, it requires feed rate. When it said G1, it always asks feed rate. How fast you will feed rate, I compare it in real life like walking, and rapid is running very fast. And when you do feed rate, which is G1 equals linear interpolation, it always requires feed rate. The machine asking you, oh, you're walking, so how fast you are walking. So that feed rate is the one specifying how fast you are walking. So in our example, because I already put here, I'll just grab this one and put somewhere there. So the next block is G1 Z0 feed 1000. So the tool will goes from G1 Z0 feed 1000. So the tool will go to Z0 and it will go feed 1000, feed rate 1000. Millimeter per minute. Millimeter per minute means in 1 meter equivalent or equals to 1000 millimeter per minute. The tool moves from this position and it will travel 1 meter, or 1 meter is like this, right? Or 1000 millimeter. That distance from this to that end is equals to 1 minute. So millimeter per minute. So when the tool start from here and reach that end, when you when you turn on your time, when you monitor the timings, it is equivalent to 1 minute travel from this start position to end, which is 1,000 distance or 1,000 millimeter per minute. That is equivalent to 1 minute. Okay? So, because it just moved 50 mm from the top, it's just too quick. Like, Z0, the machine will move from C52 to C0, 1,000 millimeter per minute. So, it's just 50 mm. So, it's just probably 3 seconds. 3 seconds, it's already moved to Z0. Okay? So, that's how the feed rate is equivalent to millimeter per minute. But I don't want to emphasize more on that one because our next block, that's where we are going to discuss how to calculate or to get the proper feed rate in your specific tool or your cutter, which is our next block is moving this tool from that position to the other side, and what is the specific or right feed rate or how fast the tool is traveling from this side to that side. There is an equivalent proper feed rate that you have to use when the tool is cutting the part. You just don't guess how much feed rate you can put. Feed rate 1,000, 2,000. No, you cannot guess the feed rate of the tool once it cut the part. You have to calculate properly based on the formulas that we will be discussing on the next part of our block. Okay? So now, when we move, excuse me, I just drink water. So for the continuation of our program, from that Z0 feed 1000 to the Z0 origin, so the next program, our tool is supposed to will be going from this right, going to the left. Like, we are now going facing operation, cutting the part from that. So from that right to here, going to that, the command is G1 X negative 225 Y negative 125 feed 65. Why X negative 225? Because we'll just go to the left side. So our origin is from this middle, and this positioning is X positive 225, which is from our first positioning in Y negative 125. Since we don't move our Y, we just move our X going to this left. That's why our X is just going to left from the Cartesian plane, going to left side of X is negative. So that's why X negative value, which is X negative 225. And Y, supposed to be the Y should not be here. It's supposed to be, will not be included. But because this is tutorial, so I just want to show you what is the Y value. So Y doesn't change. It's still the same, Y negative 125 from that previous positioning from the right to left. And feed rate 765. Where do we get our feed rate? We can put feed rate 1000. We can put feed rate 500. We can put feed rate 2000. But where do we get this feed rate 765? Where that one came from, that value. So now, we label this as X linear movement. Linear because we move the Y G1 with feed rate. Every time you command G1, which is linear interpolation, every time you use G1, you always have feed rate along with it on that block. So when you command G1, X, Y, Z, whatever is your movement, you always have feed rate accompanied with it. So because it always require feed rate every time you command G1. Because G1 means, imagine you are walking and it requires how fast you are walking. So it requires that feed rate. That's why feed rate is how fast you are walking. And to calculate the right feed rate, the formula, I already have I already written here because we already sketched here at the bottom part. The formula of getting feed rate, what is supposed to be, you still don't know the feed rate 765. How did we calculate that feed rate 765? The formula of getting feed rate is feed rate equals RPM, which is revolution per minute, times feed per tooth, times number of flute. So what is RPM? RPM is already here in M3S7478, which we already discussed from our previous video on how do we calculate RPM, right? So because our RPM now is given, which is 478, we will put RPM equals 478, which is equivalent to our M3 is 478, the rotation of our tool. And where did we get this 0.2 feed per tooth? 0.2 feed per tooth, when you buy the insert from the manufacturer, in the label, it always stated there the recommended feed per tooth, or equals FSED, means feed per tooth, of that specific insert. So it always included there. Example, for the paste mill diameter cutter 100, the normal feed per tooth, it is on the range like 0.1 to 0.25 or 0.3, or sometimes if the cutter is like to wrapping cutter, sometimes 1.8 to 1. But mostly for the diameter 100 paste mill cutter, that insert and the normal material is steel material, they put there normally 0.1 to 0.3 or 0.25. So just for our example now, 0.2 feed per tooth. Just for our example, we will put 0.2 feed per tooth. That is always the recommended from the manufacturer. It's always there, and it's always written there on the label when you buy the insert from the manufacturer. Okay. And the number of flute. What is the number of flute? The number of flute is equals to the number of sides or the number of inserts you have in your paste mill cutter. Imagine you have this paste mill cutter. I'll get this example. I'll get this glass so that cylindrical, so that you can imagine. Imagine this is your paste mill cutter. Imagine that you have this. How many flute, or this one, the flute that I'm telling you, this flute. The flute is how many flute do you have in your paste mill, or how many sides? You will count it manually, visually. 1, 2, 3. But normally, the 100 piece mill cutter normally have 8 flute, sometimes 7 flute. It's like 8 sides, 7 sides. But just to see it, just count it visually or manually. Like 1, 2, 3, 4, 5, 6, 7, 8. So meaning you have 8 inserts around it for your paste mill cutter. So that is the number of flute, or the number of sides you have, or the number of insert you have in your diameter 100 paste mill cutter. Okay? So in our example, normally the 100 paste mill cutter has 8 flute, or 8 sides, or 8 inserts on it, on that cutter, no? So, okay, so just multiply those, because the formula of getting feed rate is RPM times feed per tooth times the number of flute. Multiply all those and we will get this 764.8. Let's say in our calculator, if it's really the one, if it's really that. Okay, 478 times 0.2 or 0.2 times 8 flute equals 764.8. That's what we put here. That's what we put here in our answer. So to answer the question here, in feed, what is really the feed? So feed 765, we just round it off. Feed 765, it's because we use this formula or calculation of getting the right feed rate in your specific cutting tool, which is your paste mill diameter 100 with 478 RPM, which is your M3 is 478 here, with 8 sides or 8 insert on it, and the manufacturer recommendation, which is 0.2 feed per tooth that we use in this tutorial. That's why we get that result, which is 765. Can I put 700, 800? Well, yes, just calculate it properly. You can probably increase your feed per tooth. Example, you can put 0.25 here, but make sure that whatever feed per tooth you have used here, make sure that it is still on the range of the recommended from the manufacturer. Example, the maximum feed per tooth that the manufacturer recommended for that insert is 0.35 or 0.3. Let's put an example here in our calculator. Example, 0.3. So 478 times 0.3 times 8 fruit equals 1,147.2. We can put feed rate 1,147 here on this block, but make sure that you will not be exceeding on that feed rate, because based on the manufacturer recommendation, feed 0.3 is the maximum feed per tooth that you can use on that specific insert. You can use up to maximum 1,147 feed rate for that specific cutter. So in this specific, let's just put in the 765. So regardless of your material that you are cutting, make sure that you are just on the range of that feed per tooth recommended by the manufacturer. If the feed per tooth minimum is 0.1, you can use 0.1. You cannot also use below that minimum. Like if the minimum is example 0.1, then you will use 0.05. It's also not recommended, because meaning if you also less to that feed per tooth, your insert will probably get easily, your tool life of your insert will also get, you cannot get the maximum tool life of your cutter or your insert once you go out on that range from the manufacturer recommendation. So normally you will see in the FZ or feed per tooth in the insert box, you will see FZ 0.1 to 0.3, something like that. So just for the sake, use 0.2 so that you're just in the middle of that recommendation from the manufacturer. Okay, so that's what the answers comes out with feed 765 because of formula that we use in getting feed rate, which is RPM times feed per tooth times number of root. So yeah, thank you, and please join Filipino Machinist group overseas. Just find it in our blue apps and see you there. We have previous tutorials that we have uploaded already there. So if you miss some of our tutorials, just go in our groups and you can review and watch the previous vlogs, and so that you can follow us in our next tutorials. Okay, see you, and please subscribe to follow in our account, Jumel Ignacio Official, and thank you and bye-bye.